Know the properties, temperatures, etc. that affect the flow characteristics of the products you place in your mineral filler silos. Don't put something like this in something like the silo in the middle picture and not expect a bridging problem. Some projects require a mineral filler of sorts to be added to the mix. Do not presume a material like this will flow through a silo like this. Since the material manufacturer deals with their product regularly, they should have specified what storage and metering systems best work with their product. The silo in the middle is good for flowing materials like baghouse dust, cement, and fly ash, but not dolomite. As you can see, dolomite is nowhere near being fluid. The silo on the right has a 60-degree cone necessary for hydrated lime and difficult materials such as the one pictured. A wrap bin is different than a cold feed bin. You can't put a wrap in a cold feed bin and not expect bridging problems. Regarding bridging problems, the vertical silo kept near full with a round 60-degree conical discharge is a much better choice than the shorter silo with less head pressure and a square 45-degree cone. Reintroduction of baghouse fines. Baghouses store and introduce fines into the mix, so it not only qualifies as pollution control, but as storage feed or bin. It does a better job at pollution control than feeding the dust into the mix proportionately. One of the primary advantages of the baghouse over the scrubber is the ability to capture and reuse the aggregate fines in the plant process. By reusing fines, purchasing mineral filler can oftentimes be avoided. The amount of dust collected in a baghouse depends upon plant capacity, baghouse size, filter cloth selected, and the quantity of fine materials in the aggregate feedstock to the dryer. When filter bags are cleaned, the dust falls into a collection hopper in the bottom of the baghouse. There is at least one screw or drag in this hopper that transports the dust into the plant process or transferred to a storage silo for reintroduction to the mix. The aggregate drying process inherently separates the fines from the aggregate. When the air velocity changes through the dryer, due to production, moisture, or temperature variations, so does the size and amount of fines separated. Consequently, the loading of the baghouse changes, and so does the amount of dust returned. Complicating the issue further, the baghouse discharges the dust in sags and surges. Testing shows the average variation to be nearly plus or minus 21% over a 30-second period of time. Adding insult to injury, hot stops allow the bags to relax when the fan is turned off, causing most of the dust to fall and fill the auger below. When the plant is started again, the dryer initially sees the full auger surge, up to 59%. Since the bags released most of their dust during the hot stop, the augers will then run empty until the bags build up the dust cake again. This situation causes the dust discharge to go from the surge to a sag, 59%, until the dust cake slowly builds up over a 5-minute period. Baghouse dust is continuously fed to a surge bin. In order to use all the dust while smoothing all the sags and surges, the operator sets his vane feeder discharge speed so the level fluctuates between the low and middle level bindicators during normal operation, and between the lower bindicators and high level bindicator during a hot start. The surge bin should be sized to absorb these fluctuations. When rejecting, the operator can set the dust flow controller to the percentage wanted. The flow scale, or weigh pod, reports to the controller and increases or decreases the vane feeder depending on the plant rate. The excess fills the surge bin and is rejected out the second surge bin auger discharge port.